Hello, welcome Advanced Algebra with Trigonometry class. Take out your notes. Let's get rolling. Here are your notes on 14.1. Title for today's section, Graphing Sine, Cosine, and Tangent Functions. As you're writing this down, just kind of like a little familiarize yourself with stuff that we've basically already done. We're going to be putting some vocabulary words into play in this section. We've already graphed the sine and cosine graph when we did the butcher board project, and graphing tangent was one of your homework assignments. So this will be a lot of repeated information. However, I'm going to put some vocabulary into play here and a couple applications. So away we go, 14.1, graphing sine, cosine, and tangent functions. We're going to start with vocabulary. So I'm going to start with the definition of periodic. Periodic is what each of these functions are. It means that the graph has a repeating pattern. So any type of function that's a trig function, they're all periodic graphs. So I guess the best way to define periodic is that a graph with a repeating pattern. The next thing is the cycle. Since all these graphs have a repeating pattern, the shortest repeating portion is called the cycle. So that's kind of like the book definition, shortest repeating portion and I'm just going to sketch real briefly here a sine wave, which you should all know. This was on the butcher board project. It's something we spend a lot of time in doing. You should know that where this comes from in terms of the unit circle. This is one cycle of the sine graph. Of course, it does keep repeating and repeating and repeating as you rotate throughout the unit circle, and it could even go this way. But the darkened part of the graph, that is the cycle, the shortest repeating pattern. You could have started here and here. It doesn't matter. You could start here and here and extend it out. No big deal where you start, but the shortest repeating portion is that cycle. Now a period, that's actually the length, the horizontal length. So I'll just write that horizontal length of each cycle. Changing colors to illustrate my point. Horizontal is like the horizon, so it's this way. So putting this in blue, how long is it until we've actually repeated this up and down motion? Well, in terms of a sine graph and a cosine graph, the standard graph, that cycle has a length of 2 pi. And as you rotate around the circle, you get back in the same spot again once you make a 2 pi rotation in radians, which is 360 degrees. So you could either do this in degrees or radians, doesn't matter. Now the amplitude of each graph, basically the best way to say this is how high it is. There's some formulas and stuff like that, but I guess I'll give you kind of layman's terms. I'll call it height from middle to, I'm going to go with peak. I think that's the best way to say it. And I'll use a black marker to illustrate that. The middle in a lot of trig graphs is the x-axis. It's not always the x-axis. We're going to shift these things around. But the amplitude is kind of this height here. I will call that A because usually A is worth amplitude. We'll learn about that a little bit more. And then frequency is the last thing that we're talking about. And I guess frequency, the best way to say that is number of cycles per second or per unit of time. Number of cycles per unit of time. Many of you are doing projects and like and stuff like that. How many times, if you did weather, what's the frequency of these up and down motions? And usually there's one frequency per year for a the weather patterns. But we'll get into that more when we do an application problem. The next thing I'd like you to write down is this function, which is our general function using a and b. Y equals a sine bx and y equals a cosine bx. We're going to begin by talking about sine and cosine. Okay, so let me kind of cover up some of this so you're only looking at the key elements. So we're starting with those two important functions. A and b represent numbers, of course. And now you don't have to get all this down word for word, but just let's kind of summarize and take a look at it. And if you want to take any notes on it, you may. The amplitude and period graphs of y equals a sine bx and y equals a cosine bx. A and b are numbers, okay? Non-zero, can't be zero or else sine would be wiped out. And real numbers, okay? No imaginaries here. And here are basically, now these I think are definitely two things I would get down if I were you. Amplitude is the absolute value of whatever that number is in front of the SIN. Okay, maybe it's like a 5. Then the amplitude would be 5. Maybe it's negative 5. The absolute value of negative 5 is still 5, so the amplitude is 5. Amplitude is a distance, so that's why we absolute value it. We want to just kind of know how long that is. Period is a distance too, so even though you could put a negative number in here, we want to flip that to a positive number, and the formula for the length of the period is 2 pi divided by b. These formulas will come into play. They could be memorized. I prefer to think through the period as opposed to kind of memorizing that formula, but you could do either, and amplitude, you'll see from the graph, it's pretty easy. So, you know, here's two examples. You do not have to write these down, but I'm just going to rifle through them fast. The graph of y equals 2 sine 4x has an amplitude, absolute value of a is that number of 2, and a period of, okay, this is 4, so now if I take 2 pi and divide it by the absolute value of 4, which is 4, then my period is actually reducing that to 1/2 pi or pi over 2. And this one's real easy also. The amplitude is 1/3. That means it's a shorter graph. This graph here is a taller graph. The peaks and valleys will be spread out. This one will be squished a little bit. And now this cosine actually has a pi in it, so that's interesting. So the period of this graph would be 2 pi divided by, holy smokes, 2 pi. So the pi's go away, and your actual period is only 1 unit. So the most important things on this slide, remember, is amplitude is absolute value of a, and period is 2 pi over the absolute value of b. All right, moving on. We've graphed the sine graph on our calculators. I just wanted to remind you that you type it on in, y equals sine x. Here's what it looks like. Be wary of the mode you're in. Be wary that you're doing zoom trig. You know, all that information. So that's the sine graph, that's the cosine graph. We've already gone through all that. So the calculator part of this is not so bad, but there will be a no calculator portion where you're going to have to be able to sketch some of these out by reasoning them through. So here's example 1. We'll start with example 1a. I'll cover up 1b, so start writing it down. Y equals 1/2 cosine x. This is a piece of cake. You should kind of have memorized what cosine looks like. When you draw trig graphs, instead of drawing your standard coordinate plane like this, you're going to want a really long x-axis to show the cycles, and you don't have to have that big of a y-axis. You can shorten that up. Now cosine. I think about this first of all. Does cosine start in the middle, or does cosine start up high? Probably should be memorized. If you don't have it memorized, you think of the unit circle. You think of this beginning ordered pair, which is 1, 0. The cosine is the first number, so you start at 1. So you're starting up high. And then when you get to this point is 0, 1. So then you're going to hit 0 somewhere because you're thinking of the x values. This point is -1, 0. So now we're at -1. And then this point here is 0, -1. So we're only looking at the x's, so we're back to 0. And then when I get back over here, it goes back up to pi. This is one cycle. So connecting them, I connect them like this and like this. this, and you're drawing one period or one cycle of the cosine graph. Now, the x-axis can be labeled in radians or degrees. We're used to labeling them, or you should get used to labeling them in radians. So halfway around the circle is right here, so this is going to be pi. This is going to be pi over 2. This is 3 pi over 2. And this ending spot is 2 pi. Okay, every one of these is a quarter turn. Of course, it hits all these values in the middle here, square root of 3 over 2, 1/2, etc., but we'll leave it like that. That's it. That's all you have to do. Done, except for the half. Holy smokes, what do? Normally, you go up to 1, but the amplitude is half, so I'm only going up to half, and the lowest it goes is down to negative 1/2. There you go, y equals half cosine x. Let's move on, shall we? Now I'm not going to change the number in front, so the amplitude here will be 1, our standard graph, but now I squeeze a little number in here. All right, changing colors to illustrate my point to blue. I'm just going to kind of go back to my formula page, which is the last page. Number in front of x. Number in front of x. Number in front. That's the b. b deals with period. 2 pi over the absolute value of b. 2 pi over the absolute value of b. Period equals 2 pi over the absolute value of 1/2. You cannot divide fractions, so 2 pi times 2 over 1, which equals 4 pi. You should get really good at sketching these. Here they go. My period begins at 0 and ends at 4 pi. So this is what I want to do. So the middle halfway point is 2 pi. And because the unit circle breaks into fourths of circles, this would actually be pi, and this would actually be 3 pi. So I'm counting by 1 pi's. Interesting. Amplitude is 1, so I'm going to go up to 1 and down to negative 1. Changing colors to black. Sine starts in the middle and goes up and down here and up. Hence 1 period. Of course, this continues forever. You could draw arrows. It's certainly acceptable to do that, and you probably should. Now, compare this to y equals sine x. Well, let's just think about this for a second. I'm not going to do all of these right now, but I'm going to think about, okay, what happens if I put a pi in here? Let's think of my ordered pair. Y equals sine 1/2. Let's talk about putting in pi for x. What is my y value? Well, if I did an ordered pair, x, y, I replaced x with pi. What is my output? My output is the value of y. So 1/2 of pi, sine of pi over 2, sine of half pi, sine of half pi, sine. Oh, there's half pi. Sine of half pi is sine is the second one. 1. Pi 1. Holy smokes. Over to pi, up to 1. That was my ordered pair. You could do that with all of these. It would lead to similar results, which would give you the points that lie on this curve. Of course, you could type this into your calculator, but I'm trying to do this all by hand for you. All right, moving on. Graph y equals 2 sine x over 4. Just a little hint for this one. You could certainly write this like this. I would let's do 1/4 like that. I would suggest the sub would stop the video here for a moment and then restart it up in about 2 minutes and see how many people got the right result. I'm going to be placing my graph down here. Let's see how you do. Stop the video. And we're back. Here we go. Ready? Amplitude equals 2. So I'm going to go up to 2 and down to negative 2. That's how high I go from the middle. Sine always starts in the middle. Okay. Period is going to be 2 pi divided by b. b is 1/4. Interesting. So 2 pi times 4 is 8 pi. So my ending is 8 pi. Halfway is 4 pi. Okay, half of that is 2 pi. So there's a 2 pi difference, so that would be 6 pi. And here we go. Up the hill, down the hill, and back up. And there you have it, 1 period or cycle of y equals 2 sine x over 4. Feel free to check it on your calculator. Moving on, we're going to try and wrap this up in a few minutes here. All right, next one. Holy smokes, a story problem. This is very similar to the story problem on page 833. You'll have my example to take a look at, and you will have the book example to take a look at. And it's really kind of shows you how to do this pretty well. A tuning fork vibrates with a frequency of 880 hertz. That is cycles per second. So if you ever see a tuning fork, you hit it, goes bing, and vibrates back and forth very quickly. You strike the tuning fork with a force that produces a maximum pressure of 4 pascals. Now, I'm not going to get into the what the heck is a pascal. You just have to know that that's a measurement of pressure, just like meters is a measurement of length. Write a sine model that gives the pressure P as a function of t in time and graph the model. So here's my equation. I need a sine equation. Y, oh, I shouldn't do Y. P, we're going to use P. P equals, okay, normally there's an A. I'll just put an A here. A sine of BT. Do I want T? Yeah, T seconds, good. So, okay, so that's how we normally do this. Now we got to find A, we got to find B, and we're done. The key here is what the heck do I do with this? Now remember, there's a hint here. This is cycles per second. So frequency is basically how you calculate it is 1 divided by period. That's how you do the frequency. Okay, so now what is the frequency? The frequency is 880 hertz. 880, and said this formula is in your book, by the way. Okay, cycles per second, and this is period, so don't think that that's per. Okay, this is 1 second, cycles per 1 per second, and then 1 divided by period. So normal period for a sine graph is 2 pi. Okay, so now I'm going to solve for B here. Okay, so 440, actually I'm going to make this formula for frequency here is B divided by 2 pi. Okay, so we got 1 over the period, and in this case it's B divided by 2 pi. So I'm going to solve for B. B equals 2 pi times 880. Okay, 2 times 0 is 0, 16, carry the 1, 8, 16, 17. 1760 pi is my B. So that goes in right there. So I'm starting to write my equation. P equals sine of 1760 pi B, T, sorry, T. Okay, sine BT, that's my B. Okay, and then I need this A. Well, that's the maximum pressure. You just kind of lop that on the front there, and that's your 4, that's your amplitude. So that's your formula. It's pretty easy to do that. And now you have to just go to your graph. So here's your graph for sketching. Your B is this guy. So to figure out what your period is, period equals 2 pi divided by B. 2 pi divided by B, which is 1760 pi. The pi's cancel. And what the heck is 2 over 1760? Oh, look at that. That's a magic 880. Very interesting. Actually, it's 1/880th. Look at how this graph is going to end up. 1/880th. Very interesting. Okay, and halfway, and halfway, and halfway. So you split it into force. Sine starts in the middle, kind of comes up, goes down, and comes back, and label your y-axis to be 4 and -4. Now, this is kind of, really spread out and zoomed in 1/880th. That's really, really zoomed in. If you were to look at this graph just by looking at it, it would look like this. So, of course, we're just zooming in on one little cycle there because this period, is 1/880th. That's tiny, but that's an application of this tuning fork, and you know how it vibrates. It goes very, very fast. So see your book for another application of this. I just wanted to show you one. I'll go over this one a little bit more in detail when I can be there and answer questions. But read your book too. That's on page 883. That should help you there. That's it for today, I believe. I don't think there's any tangent questions. Let me take a peek here. There 22 is a tangent problem, so I guess I'm going to have to go back and show you a tangent real quick. The things I want to comment about tangent is that tangent is slightly different than sine and cosine. I'm going to answer questions when I get back on this, but I'd like you to kind of take a peek at page 834. There are some differences between tangent and sine and cosine. One biggest example is that the period is not 2 pi divided by b, it's only 1 pi divided by the absolute value of b. That's the only difference. So you guys all graphed the tangent graph the other day. It kind of looks like this. And then there's another one that looks like this. And then it's infinite. Whoa, it's an infinite repeat of this. And I know I'm drawing this kind of sideways, but I think you get the picture. And I hope you also remember that in the middle here are asymptotes. And that is special locations at pi, negative pi, 2 pi, etc. Why are they there? Here's an example of why the asymptote is at pi. This is pi. This ordered pair is 0, 1. And tangent is sine divided by cosine, which is undefined. That's why you need the asymptote. So that's just a quick example of tangent. And really quickly, I'm going to do one of these, just in case if you'll have to do this on one of your assignments today. So normally, we go from pi to negative pi on a tangent graph. And that period then, okay, is basically, from here to here. I actually did that wrong, didn't I? This should be pi over 2. My bad. Sorry about that. This is pi over 2. Because this 1, 0, I did it right here, but I kind of labeled it wrong. Pi's over here. It's 0 at pi. So this one right here is pi over 2. My mistake. Glad I went back to catch that mistake. All right, so basically your period here is pi units, because this is half a pi here, and this is half a pi here, so this whole thing is pi, hence the pi over 1. So now your period is pi over b. This is your b. So I do pi divided by pi over 2. That will give me my period length. So pi times 2 over pi. Pi's cancel. Your period is 2. Just 2. So the length from this line to this line is 2. So I wonder how far this is. Oh my goodness, 1 and negative 1. That's where your asymptotes go. And now I'm just going to draw in that tangent curve. However, the 3 changes, it's not really amplitude because tangent goes on forever here, but this is what the normal tangent graph would look like. I'm going to draw it in green, and then I'm going to try and draw over it. It kind of goes like this and goes like this. However, the 3 kind of stretches it like the way we normally put numbers in front of functions that stretch it, so it makes it a little bit taller. And I'm not going to be picky on that, but it's going to kind of look like that. Okay, and you could do this on your calculator to see the difference. Don't put the 3 in there, then put the 3 in there, and kind of verify it. I'm not really going to be that picky about this number. I am going to be picky about the period and you being able to label this is 1 and this is negative 1, since the length of the period is 2. Same formula. Thank you very much for coming today. Hope that was enough. This is kind of the information you're going to need for the next 2 days when we work on these lessons. So here is your assignment 14-1, page 835, 17 to 22 all, and 24 to 42 all. Thank you, Mr. Substitute, for substituting for me today. And you can work on your assignment now and make sure you finish this up for tomorrow. Thanks for coming, and have a good day.